In this sample problem, we are asked which reaction predominates when an NaHSO3 is dissolved in water to produce a HSO3- aqueous solution. So in order to solve this, we need two chunks of information off of our acid-base table. We need to find the row with HSO3- on it, and we also need to find its conjugate acid, H2SO3. So for the H2SO3, HSO3- conjugate base pair, or conjugate acid base pair, we see that the Ka is equal to 1.4 times 10 to the negative 2. We also see for the HSO3 minus SO32- conjugate acid base pair, we have a Ka value of 6.3 times 10 to the negative 8. Now, when I was in Chem 30, this is the place I would always get stuck, because it's always going to be the Ka that's higher up is going to be the bigger number. And we are going to use that higher up Ka, but we also need another number. Whichever pair is lower on the table, which will be the one you're actually talking about, the HSO3-, we need to calculate the Kb. So Kb, even though it's not given, we can calculate it as being equal to Kw over Ka. We have the Ka value, and we know what Kw is. Kw is 1 times 10 to the negative 14. Ka is 6.3 times 10 to the negative 8. Now we just have to plug that into our calculator, and it'll tell us what Kb is. So 1 times 10 to the negative 14 divided by 6.3 times 10 to the negative 8 gives us 1.6 times 10 to the negative 7. Okay. So then, is this chemical going to act as an acid or a base? Well, whichever one is higher indicates which way this is going to go. Is it going to turn basic or is it going to turn acidic? And we can see that the bigger number is the Ka value. That means that in water, HSO3- is going to act as an acid. So the overall reaction that will be taking place will be HSO3- plus H2O, aqueous and water, or liquid, will react in equilibrium to become SO3 2- and H3O plus. The reason it's doing that is that this particular species is going to act primarily as an acid.